Okay, so let's do another method. Let's do the first fit. And decreasing just means it's in decreasing order. So again, our list of cuts, we got 4 6s, 3 5s, 4 4s, 4 3s, 2 2s, and 4 1s. So that's our list of cuts out of the 8-pound bins or 8-foot boards. First fit says put the next weight in the first bin in which it fits. I think you'll see this makes a little bit more sense than the other one, but we'll see. First fit, put it in the first bin in which it fits. So we can start off, and we know we're going to have to cut 6s because that's not going to fit. All right, so we get those 6s. And then the 5s, it's not going to fit, so we're going to go ahead and cut our 5s because none of those will fit. And then we've got the 4s, and those 4s won't fit. Well, the first one won't. And now the second one, okay, the second one will fit. So we're right there. All right, this looks a lot like the last algorithm. Everything's the same so far. Third one won't fit in any of them, so I'll open up a new bin. And then the fourth 4 will fit right there. Okay, now, so far this is exactly the same as next fit that we just did, but here's where it gets a little bit different, and here's where it makes more sense. This 3, we put it in the first bin it'll fit in. So this one. Okay, that makes sense. And then we've got another one, first bin it fits in, another one, first bin it fits in right there. Okay. This next one won't fit in anything, so we open up a new bin. Makes sense. And we go with the 2s. So our 2s, put it in the first bin it fits in. Well, it's going to fit over here. And then another 2 will fit right here. Okay, great. Then we can do the 1s. It's going to fit right there, and then there's one right there, and then there's one right there, and then there's one right there. Okay, great. That looks pretty efficient because we've used up 9 boards completely, and then we bought a 10th board. So number of bins needed is 10. And you can see we've wasted this 5 feet right there. But look at your totals. We bought 10 boards or 10 bins, and they were 8-foot bins, so that's 80 feet total. And so your waste would be 5 out of 80. Or 6.25%. We've got 6.25% is the waste. Okay? So number of bins needed, 10. That's the important answer. And that's a little bit more efficient than the last algorithm where we had 12 bins and 21.875% waste. This is a lot more efficient. So now we're going to do the best fit, decreasing. And again, the cuts are 4 6s, 3 5s, 4 4s, 4 3s, 2 2s, and 4 1s. So best fit, go back and look. Best fit, put the next weight in the bin with the least space. Okay, may or may not be same as the last one. Best fit, least space. If the weight won't fit, open a new bin. So best fit, least space. So you can go ahead and start with the 6s because you know you're going to need 4 boards for that. Go to your 5s. Okay, least amount, it's not going to fit, so we can go ahead and put 5s here. Your 4s. going to be able to fit a 4 here. Likewise, 4 and 4. Okay. Now, when you get to your 3s, you can use your old bins, and it says put it in the one with the least amount of space. Well, that's like right here, but that's not going to fit. So the least amount of space in which it will fit. So you could put one of those 3s here, and then another 3 here, another 3 here, and then your 4th 3, you're going to have to open up a new bin. Okay. So this is exactly the same as the last one so far. Let's see if it continues. With your 2s, we need a couple of 2s, so put it in the least amount of space, so that's here and here, okay? And then your 1s, put it in the least amount of space, so you can put one here, you can put one here, you can put one here, you can put one here. Yeah, it looks like the exact same solution as the last time. We need 10 bins. We've got this 5 feet of waste, and 5 out of 80 feet. Remember, it was 10 times 8 feet is 80 feet. 5 out of 80 was 6.25%. That was our waste. Okay, that's best fit. Now, keep in mind we didn't really follow the same algorithm as first fit. We just ended up with the same answer. Best fit, put the next weight in the bin with the least space. Worst fit, we're going to put the next weight in the bin with the most amount of space. So, what is this? Again, decreasing just because these numbers are in decreasing order. They may or may not be in decreasing order when you see them the next time. Worst fit. Put the next weight in the bin with the most available space. Start with your 6s. It's going to seem like we're doing the same thing over and over again, but there's subtle differences. Okay, your 5s. Your 4s. Now, here's where I've seen in the past, people will say, well, wait a minute, the most amount of space, wouldn't I just start a new bin? And it's like, no, that's not what I mean. You still are trying to minimize your number of boards. When I say the most available space, it's in a bin that you've already opened up, okay? So that second 4, you're going to need to put it in the bin with the most available space, which is right here. Your third 4 isn't going to fit in an open bin, so we're going to have to start a new one. And then your 4th 4 is going to have to fit here. Okay. Next one. Okay, it's still going to look the same right here because you need to put your 3s in a bin with the most available space. That's right here. And then the second 3, that's right here. The most available space, the most available space. Okay, that still makes sense. Not enough room, so you put it in the most available space. That's right here. Okay, it seems like we're doing the exact same thing every single time. That's just the way these numbers are working out. But now it's different. This 2 right here, you have to put it in the bin with the most available space. That's what the algorithm says. Okay, so that 2 is actually going to go right here, the most available space. Okay, now you've got another 2. It's got to go in the bin with the most available space. That's right here. And so that's definitely different, right? That's definitely different. Now, keep rolling here. We're going to do the 1s. So your first 1, you put it in the bin with the most available space. I'd say that's probably right here. I know there's a tie, so if there's a tie, we'll just go to the left. Now you've got another 1. Put it in the bin with the most available space. Well, here's one right here. And then another one right here. and another one right here. To me, I don't like this because I've got to do all these extra cuts and I've got all these little bitty pieces left over, but you still need 10 bins. And if you look at the wasted space, you've got 1, 2, 3, 4, 5 feet of wasted space. Okay. So 10 boards, 8 foot, that's 80 feet total. The waste is still 5 out of 80, which is your 6.25. So it's still the same solution basically, but, okay. Can anybody tell me why I might rather this solution? Yes. Would it be less cuts? Would it be less cuts? Yeah, maybe. I kind of like having a 5-foot board left over. Maybe I could use that for another project sometime, as opposed to this one. Say you've got 5 separate 1-foot boards left over. Maybe I can't use those. Maybe I can use a 5-footer. I don't know. It's kind of your preference. As far as cost, though, the cost would be the same. 10 bins, which is much more efficient than this one, which was 12. So keep in mind, you're just trying to minimize your costs.